In this video, we're going to look at making measurements. You're going to be flipping cartwheels for the next 15 minutes. You're going to love this. A lot of this, again, should be reviewed from last year, which is really the first time that you pay more attention to the measurements that you're making in the lab. The term significant figures may be running through your mind at this time. You loved those, right? Of course you did. That's why you're taking another year of this, huh? Do you remember that when you make a measurement, you have to look at the markings on your measuring tool, and you record all the measurements that you can get for sure, plus the one estimate. And that's usually where people lose a half a point on their measurements or in their lab reports. But they just kind of estimate when they're using a graduated cylinder or a ruler. I don't know, it was like about 20.1 milliliters or something like that. But we have to look at the measuring tools that we're using to really determine the amount of figures that we should be reporting in our measurements. All of the graduated cylinders are a little different. Some have more precise, more detailed markings than others. For example, if a student made this measurement 20.15, 0.14, 16, 17 milliliters, this must be some kind of a volume measurement on a graduated cylinder. The graduated cylinder must look something like this. Okay, so my fabulous art skills. Graduated cylinder. They knew for sure that the volume hit the 20 milliliter mark. There is a mark for 20 milliliters. Boom. 20 milliliters. There's a line for 20 milliliters. There must also be a line specifically for 20.1 milliliters. This graduated cylinder is marked off every 1/10 of a milliliter. So here's 20. This would be like 20.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and this up here would be 21 milliliters, and so on. Because I'm going to make a measurement, I record everything I know for sure, and the last spot is the estimate. Oh, okay, it's this guy right here. This 5, 4, 6, 7. Those were the estimates. I will never mark the estimate wrong. So all of those measurements could be from the same graduated cylinder. 4 kids made the same measurement on the same graduated cylinder. They all get full credit. They all made a proper measurement. The last figure is estimated, as long as it's obviously within reason. So this might have looked something like, oh yeah, let's make it, I don't know, water or something. I'll make it blue. It hits the 20.1 for sure, and the rest is up to your discretion. So there's my little meniscus. And so now I read to the bottom of my meniscus. So within a reason, you get the point, right? That's kind of what the graduated cylinder would have looked like. We know for sure it hits the 20 milliliter. We know for sure it's the 20.1. And it's somewhere between 20.1 and 20.2. So as long as, again, we have a reasonable estimate, A+. Now, sometimes people will say, oh, I don't know, it was just really close, so I didn't take an estimate. Well, then estimate 0. You have to take that last spot as an estimate. What often happens is then we use these measurements in further calculations. Maybe we're doing density or molarity or something like that. We need the volume measurement. The number of figures reported in your volume measurement will determine the amount of figures you can report in your final calculated answer. Remember those sig fig rules? Oh yeah. They're going to come back. We're going to go through those again. You're going to love it. So it is very important. Even if you think that it's right on the line, take an estimate of 0. Awesome. Other things that we should make note of. Again, the amount of figures you can report is dependent on the measuring tool you are using. So again, different graduated cylinders will be able to record different amounts of decimal spots. Here we have a bathroom scale and electronic balance. Now these are measured in pounds, and we're never going to use pounds in the lab. We'd use grams, but I can deal with it. We're measuring some grapefruit. Awesome. The bathroom scale must only have 1 decimal spot. On the bathroom scale, it looks like they both have the same measurement, 1.5 pounds. However, if I have the opportunity to use an electronic balance that allows for more precision, a more detailed measurement, now I can see that those measurements are not exactly the same. If I'm rounding them to the nearest tenth, then yeah, they're both going to round to 1.5 pounds. But if I'm able to leave more precision, great. Then no, those are not the same. Now again, with electronic balances, and again, maybe a digital thermometer, you do not need to take an estimate. There you just record whatever the thing says. Sometimes people will ask that, well, how do I make an estimate on the electronic balance? And it's a great question, you really can't. So if you were using an electronic balance that measures out to 3 decimal spots, that just is what it is. The ones that we'll use in the lab usually use 2 decimal places. So I guess, do the objects have the same mass? Depends on the balance that you're using. With a bathroom scale, 1 decimal spot, yeah, I guess. But in the electronic balance with more precision, no, they're not exactly the same. What is the difference between 25 and 25.00 milliliters? If you're measuring, I guess here. With this one we can say, same mass? Sure. If it bothers you. Same mass? No. Depended on the measuring tool we were using. It says 25 versus 25.00. This comes up a lot. In AP problems, they'll give you a whole bunch of sample data. And then often, again, you have to do some kind of calculation with it. And so then maybe it's density. The problem says 25.00. In their calculation, they use 25. Because they're like, well, 0.00, zeros are nothing, so why write them, right? Saving my pen, ink, or my pencil lead, I don't need to write those zeros. Oh, yes, you do. These are not the same measurement. If you have 25.00 listed in the problem, and you do your work with 25, half a point off. And this is, again, something where people will come up to me after tests, and I'll say, like, well, I think you made a mistake. You took off half a point on mine, but my friend got full credit, but we really did the same calculation. Actually, you kind of didn't. 25 milliliters. If I measure 25 milliliters, the graduated cylinder might look like this. Graduated cylinder. The last spot is the estimate. So if it was 25 milliliters, this 5 is the estimate. There we go. So this means that they knew for sure it hit 20. It did not hit 30. So they estimated, I don't know, like 25, somewhere in there. Here's what the graduated cylinder might have looked like. 20, 30, 40, and so on. And maybe their meniscus was something like that. So they estimated, I don't know, it's like right in the middle, 25? Somebody else might say 24, 26, A+. Those are all fine. You might remember significant figure rules, which again, we're going to go through in just a little bit. Not this video, another one. But this has 2 significant figures. Significant figures are all the measured numbers plus the estimate. 1 measured number, 1 estimate. 2 sig figs. This guy is a little different. 25.00. Way out here in the 100th place. That's the estimate. This graduated cylinder would look very different. Graduated cylinder. There's a line for 25. There would be a line for like 25.0, 25.1, 25.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 26 milliliters. Okay, so now here's what this might have looked like. I'll put in my meniscus. It's way down here by the 25. read to the bottom of the meniscus. They know for sure it hits 25. They know for sure it does not hit this guy. This would be the 25.1. So they say, okay, 25.0 doesn't hit the 0.1. But then you still get an estimate. So if you think it's right smack on the line, just say 0. This measurement is 4 significant figures. All the measured numbers plus that last estimated 0. So do zeros mean nothing? I don't know. In this case, I would say not necessarily. The zeros are important because they're going to determine how many figures I can leave when I do a calculation now with these measurements. What is the difference between these two? The amount of figures. They were measured on very different measuring tools. And so again, if I'm making a measurement on the graduated cylinder, we've kind of drawn a few graduated cylinders. You got to look at the markings. This is 80, 90, and then in between this must be 81, 82, 83, 84, 85, 6, 7, 8, 9, 90. This graduated cylinder is marked off every 1 milliliter. This is very similar to the 100 milliliter graduated cylinders that you'll have in the lab. Okay, so if I'm making a volume measurement, not a bad idea to crouch down to eye level. So here's crazy eye level. Read to the bottom of the meniscus. We record everything we know for sure. I'm pretty confident that this hits 80, 81, 82, maybe 82, but not quite 83. And so then the last spot is my estimate. As long as it's reasonable, A+ to you. I don't know, maybe it's a little bit closer to the 83. I'll say 82.6 milliliters. Milliliters. Whoa. Milliliters. If somebody else says 82.5, 82.7, A+. Those are all reasonable. So graduated cylinders, look at the markings on the tool. They are all a little bit different. Not a bad idea to be at eye level. And then take your estimate. And if you think it's on the line, you estimate 0. The other measuring tool that we should just mention quick is a burette. We'll use burettes a few times throughout the year. You may have used these in the past, like when you did a titration, probably with acids and bases, right? You're neutralizing some kind of acid or base by delivering a volume from the burette. Sometimes people have trouble measuring with burettes because they're kind of opposite a graduated cylinder. They look similar, they measure volume, but burettes measure volume delivered. So you fill your burette, and this is just a snapshot, but at the very top of this thing, wow, if this goes all the way up to the top, the last marking is 0. And so usually in the directions it'll say fill your burette to the 0 marking. And then you have to record your initial burette reading. That's usually how it's worded. Record your initial burette reading. And so if you really did start with your volume way up on the top, your initial reading is 0. And that's where people are a little confused because they're wait a second, I don't have 0 milliliters. This is probably a 25 milliliter burette. And so they have a little apprehension, but it's not 0, it's not empty. Oh, but it's 0 milliliters delivered. Your initial reading is always 0 on a burette because you have not delivered any volume yet. And so then you might remember, you open up the burette, there's that little stopcock trigger on the bottom, and you release that volume, and often you release it until your final solution is neutral or something like that. And then you take the reading of volume delivered. So these guys kind of read backwards. They're going to read from the top down. You're reading the volume delivered, not the volume in the burette. Oh, so I have delivered, okay, let's check these markings. This is 20. It came from this little snapshot here. 20, 21. It's got all the milliliters marked off. Plus, in between, this must be like 20.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 22. This thing must have the tenths also marked off. Okay, so this guy right here is like 20.1. This is 20.2. And so on. Well, I know for sure I delivered 20.1. It's beyond the 20.1. It's somewhere in between. So I'm going to guess, estimate 20.1, I don't know, 4? Something like that? As long as it's reasonable. Milliliters delivered. This is the estimate. I did not deliver 20.2. I'm not quite there yet. Volume delivered, top down. So I'll estimate, I don't know, 1.4, 1.5, something reasonable. Gets you A+ full credit.